Hi friends, this is your Srinivas Mathematics faculty. In this video, I am going to explain about you more two trigonometric functions graphs. They are y is equals to tan x and y is equals to cot x. If you like this video, please share and subscribe and encourage me to make more videos for you. And watch this video till to end. See, already we have discussed in our earlier two videos about two trigonometric functions graphs. They are y is equals to sin x and y is equals to cos x. And also we have discussed their nature. So now you see y is equals to tan x. This is our third trigonometric function graph. Here when x is equals to 0, tan 0 value is 0. When x is equals to 30 degrees, tan 30 degrees is 1 by root 3. 1 by root 3 we don't know exactly, somewhere here, but it is positive. This is x is equals to 45 degrees. For x is equals to 45 degrees, tan 45 degrees value is equal to 1. When x is equals to 60 degrees, tan 60 degrees is root 3. Root 3 value is 1.732. On x-axis, suppose 1 is here, 1.732 means somewhere here. X is equals to pi by 2, tan pi by 2 is undefined. Undefined means infinity at the extreme stage of y-axis. This is minus infinity. Similarly, for minus 30 degrees, tan of minus theta is minus tan theta. Minus 30 degrees, tan minus 30 degrees will be minus 1 by root 3 somewhere here. Minus 45 degrees is equal to minus 1. Minus 60 degrees somewhere here. And for minus 90 degrees it is does not exist, means minus infinity. Now the tan x graph between minus pi by 2 and plus pi by 2 will be like this. Okay? Next, after pi by 2, somewhere here 120 degrees. After 90 degrees, 120 degrees. Tan 120 degrees, whichever the value, in second quadrant tan is negative, we get below x-axis. For 150 degrees, it may be somewhere here. For 90 degrees, a right side stage somewhere here. By going on, these are the values. At pi, it is 0. After pi, pi to 3 pi by 2, it is third quadrant. In the third quadrant, tan x is positive. So that for all these values, graph of tan x will be above x-axis only. For example, these are the values. Now, the graph of tan x will be like this. Between pi by 2 and 3 pi by 2. So, same type of graph can be seen in the interval 3 pi by 2 to 5 pi by 2 also. Same type of graph can be seen in the interval minus 3 pi by 2 to minus pi by 2. In the interval minus 5 pi by 2 to minus 3 pi by 2 also, same type of graph can be seen. See, wherever the graph is above x-axis, for those intervals, tan x is positive. Graph is below x-axis means tan x is negative. Observe that 0 to pi by 2, it is the first quadrant. In the first quadrant, graph is always above x-axis because tan x is positive. Second quadrant means pi by 2 to pi. Pi by 2 to pi is graph is coming from minus infinity to 0. Means pi by 2 to pi, second quadrant graph is negative because it lies below x-axis. Pi to 3 pi by 2, again it is above x-axis, it is positive. In the third quadrant it is positive. This is fourth quadrant, it is negative. Of course, already we know about sign of tan x in different quadrants. And also observe that whenever 0 to pi by 2 x values are increasing, as x values are increasing, corresponding f of x values means corresponding y values are also increasing. Increasing means for this graph corresponding y value, for this graph corresponding y value, for this graph corresponding y value, for this corresponding y value, on the graph we can see only y values only. As x values are increasing, corresponding y values are also increasing. So in the first quadrant, graph is always increasing type. Second quadrant means pi by 2 to pi. As x values are increasing from left to right, graph is also coming from down to up. Means corresponding y values are also increasing. Pi to 3 pi by 2, left to right x values are increasing. Corresponding y values are also increasing. 3 pi by 2 to 2 pi, x values are increasing. Corresponding y values are also increasing. What did you observe now? Tan x is increasing in each and every quadrant. It is increasing in first, second, third, fourth. So in all the quadrants it is having unique nature. That's why tan x is always increasing function. And also observe that as we seen earlier, means in sin x and cos x graphs, graph of those curves can be drawn without lifting marker from the board. Means graph of those functions will be defined for all real values of x. That's why its domain is R. But here one thing will be happen that minus pi by 2 to plus pi by 2 graph can be drawn continuously. Then after at pi by 2 we have to lift the marker. We have to start from here. Again pi by 2 to right side 2 till 3 pi by 2 graph can be drawn continuously. At 3 pi by 2 we have to lift the marker to draw the graph. That's why pi by 2 is discontinuous point. At that point graph does not exist. 3 pi by 2 discontinuous point. At that point also graph does not exist. 5 pi by 2 also point of discontinuity. At that particular point also graph does not exist. Similarly, minus pi by 2 discontinuous point, minus 3 pi by 2 discontinuous point, minus 5 pi by 2 also discontinuous point. And observe that graph is, means tan x is not defined for minus 5 pi by 2, minus 3 pi by 2, minus pi by 2, pi by 2, 3 pi by 2, 5 pi by 2, then after 7 pi by 2, 9 pi by 2, 11 pi by 2, 13 pi by 2, etc. While observing, wherever the tan x is not defined, those values are always odd multiples of pi by 2, like 1 pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2, 19 pi by 2, 31 pi by 2, 99 pi by 2. Left side minus 5 pi by 2, minus 7 pi by 2, minus 9 pi by 2. At these points tan x is undefined. That's why its domain is not the whole set of real numbers. For each and every x values, graph does not exist. Graph does not exist for some particular x values. That's why its domain is set of real numbers minus, we have to subtract from set of real numbers these angles. Those are of same type of angles. Those are nothing but odd multiples of pi by 2. That's why r minus of 2n plus 1 into pi by 2 such that n belongs to z. This is domain of tan x. Okay, why we are subtracting some values at those points? Graph is not defined. Okay, next, what about range? It is taking y values on y-axis for this, for this. So these are y values. So y values exist from where to where? Minus infinity to plus infinity. Okay, so range of the function is whole set of real numbers, because for graph each and every point there exists corresponding y value on y-axis. That's why its range is from minus infinity to plus infinity. So range of tan x is minus infinity to plus infinity. This can also be written as set of real numbers. And observe that lower boundary, what is its minimum value? Minimum value minus infinity, which is not a real number. That's why it has no minimum value. What about its maximum value? Upper boundary of the range is plus infinity, which is also does not exist, which is not a real number. That's why maximum value of tan x also does not exist. Observe that minus pi by 2 to pi by 2, whichever the graph can be seen same type of graph from pi by 2 to 3 pi by 2. We can also see same type of graph from 3 pi by 2 to 5 pi by 2. Again 5 pi by 2 to 7 pi by 2 also same graph. Minus 3 pi by 2 to minus 5 pi by 2 also graph is same. Minus 5 pi by 2 to minus 3 pi by 2 also graph is same. See, tan x is periodic function. Just by observing the graph we can say that it is a periodic function. What is its period? Length of this interval is called period. Okay, what is its length? Here to here pi by 2, here to here also distance pi by 2. Total length is pi. That's why its period is pi. So tan x is a periodic function with a period pi and differentiability nature. See, minus pi by 2 to pi by 2, it doesn't have any sharp edge. Even it is intersecting at 0 and taking turn, but it is not a sharp turn. It's not a V turn. Moreover, it is not discontinuous between minus pi by 2 comma pi by 2. Minus pi by 2 to pi by 2, it is always differentiable. At pi by 2 it is not continuous. Because of not continuous, it is not differentiable. Again, pi by 2 to 3 pi by 2, no discontinuous point, no sharp edge of the graph. That's why it is differentiable at each and every point between pi by 2 to 3 pi by 2. Also differentiable between 3 pi by 2 to 5 pi by 2. Also differentiable between this. Also differentiable between this. Means function is continuous on its domain better. Continuous on R we can't say. We have to subtract some discontinuous points. That's why I'm saying that function is continuous on its domain. Function is also differentiable on its domain. So tan x is continuous and differentiable on its domain. It is a periodic. It is always increasing nature. And what about 1-1 nature? When we say that function is 1-1, if you draw a straight line, if it intersects the graph at only one point, then it is 1-1. Now you see, if I draw a straight line parallel to x-axis, it is intersecting the graph at more than 1 point. Even if it is intersecting in 2 distinct points, then also we can say that the function is not 1-1. So it is not 1-1 function. So it is increasing in first, second, third, fourth quadrants. Not only at these quadrants. Throughout the domain it is always increasing function only. See here, one more point. At these points means graph wherever intersecting x-axis, at those points tan x is equals to 0. That is, tan 0 is equal to 0, tan pi is equal to 0, tan 2 pi is equals to 0, tan minus pi is equal to 0, tan minus 2 pi is equals to 0. These are the values can be calculated easily when we know period of the function. For example, tan 30 degrees is equals to 1 by root 3. Tan 30 degrees is equals to 1 by root 3. What is its period? Pi. Pi means 180 degrees. Simply pi is added to 30 degrees. 180 degrees plus 30 degrees, 210 degrees definitely will also be 1 by root 3. For 210 degrees again 180 added. For 210 degrees 180 is added, we get 390 degrees. It goes to first quadrant. Again tan of 390 degrees is also equals to 1 by root 3. Very simple to identify. So tan 45 degrees is equals to 1. To get another angle where tan gives 1, it is very easy just by adding its period to basic angle 45 degrees. 45 degrees plus 180 degrees, 225. Tan 225 degrees value is also equals to 1. To get one more angle, just adding 180 to 225 degrees. Whichever the angle, for that angle, again it is equals to 1. So, it is very easy to identify the nature of the function through the graphs. Okay, we can identify continuity nature, discontinuity nature, differentiable nature, non-differentiable nature, increasing, decreasing nature, minimum value, maximum value, and one function or not. We can check very easily. Okay, now let's go to another graph, that is y is equals to cot x. See, y is equals to cot x. Here, suppose x is equals to 0, cot 0 is undefined. Cot 0 means cos 0 by sin 0. Cos 0 is 1, sin 0 is 0, 1 by 0 is undefined. Means it begins from somewhere here. Cot pi by 4 is somewhere here 1. Cot pi by 2 is 0. Cot 135 degrees is minus 1. So cot 150 degrees somewhere here. So at cot pi is again infinity. So the graph between 0 to pi will be like this. So this is cot x graph between 0 to pi. Similarly, we can see pi to 3 pi by 2. This is the graph. And 2 pi to 5 pi by 2, there is no right branch of the graph, down branch of the graph. Next, minus pi to 0, this is the graph. Similarly, minus 2 pi to minus pi, this is the graph. Thereafter, this is the graph. So above x-axis branch is not there. It may be like this. Here below x-axis graph is not there. So it is dummy graph. Observe that here cot x is defined for only the real numbers except 0. At 0 it is undefined, at pi it is undefined. At 2 pi it is undefined, again at 3 pi it is undefined. At minus pi undefined, minus 2 pi undefined. So it is defined everywhere except angles which are multiples of pi. At pi, at 2 pi, at 3 pi, at 4 pi, at 5 pi, any integer multiple of pi, cot x is undefined. That's why its domain can be written as r minus integer multiple of pi. Integer multiple of pi general value is n pi such that n belongs to z. Also observe that its range graph is taking all the y values on y axis. That's why its range is minus infinity to plus infinity, which can also be written as set of real numbers. Minimum value of the graph does not exist. Maximum value also does not exist. So extreme values does not exist. And observe its continuity nature. 0 to pi in this slot, graph can be drawn continuously without lifting marker from the board. That's why it is a continuous in 0 to pi interval. Again, it is also continuous in pi to 2 pi interval. Again, it will be continuous in 2 pi to 3 pi interval. Same, minus 2 pi to minus pi also it is a continuous. Minus pi to 0 also it is a continuous function. So observe that where it is a continuous. It is continuous everywhere except 0, pi, 2 pi, 3 pi, which are nothing but integer multiples of pi angle. At those points it is discontinuous. That's why it is a continuous on its domain better. Domain is also taking all the real numbers except integer multiples of pi only. That's why quad x is a continuous on its domain. Also differentiable because in this slot it doesn't have sharp edge. It is having no discontinuity points. That's why it is differentiable everywhere in this interval. That interval is nothing but domain. This interval is nothing but domain. So these intervals are nothing but domain. At these intervals, the function is differentiable. That's why we can say that quad x is differentiable on its domain. Continuous on its domain, differentiable on its domain, and periodic nature. Observe that while observing the graph, same type of graph can be seen for slat to slat. In this slat, whichever the graph, here also we are getting same graph. Here also we will get same graph. Same graph, same graph. That's why same graph is repeating for the interval whose length is here to here pi by 2, here to here pi by 2, total length is pi. For every interval of length pi, graph is repeating. That's why its period is pi. Cot x is also periodic function. Period is pi. So far, sin x, cos x both are periodic functions. Their period 2 pi. Tan x, cot x both are periodic functions. Their period is pi only. And increasing decreasing nature, let us discuss. 0 to pi by 2, it is the first quadrant. For this x value, corresponding y value somewhere here on the y-axis. For this x value, corresponding y value somewhere here on y-axis. Here to here, x values are increasing, but the corresponding y values are decreasing. From left to right, x values are increasing. Graph is coming from up to down. Means corresponding y values are decreasing. So that it is decreasing function. In second quadrant, pi by 2 to pi, as x values are increasing, corresponding y values are decreasing. In the third quadrant, pi to 3 pi by 2 also decreasing. In the fourth quadrant, 3 pi by 2, 2 pi also decreasing. So cot x is always a decreasing function in all the quadrants. In the first quadrant decreasing, see, cot x is decreasing in first quadrant, in second quadrant, in third quadrant, as well as in fourth quadrant. So in all the quadrants, cot x is always a decreasing function. And what about its 1-1 nature? If we draw a line parallel to x-axis, it will intersect the graph in more than one points so that it is not 1-1 function. So far, sin x, cos x not 1-1 functions, tan x not 1-1 function, Now cot x is also not one function. It is continuous on domain, differentiable on domain, always decreasing function, periodic function with period pi. Minimum and maximum values does not exist. Domain is R minus set of n pi such that n belongs to Z. Range is set of real numbers. So this is about cot x graph. In our next video, we are going to discuss about graphs of y is equal to secant x, y is equal to cosecant x and their nature. So friends, if you like this video, please share and subscribe my YouTube channel Math Tree by TS and encourage me to make more videos for you. Thank you. Thank you very much.